So, welcome back, everyone. In a previous lecture, we have discovered that AI didn't just become intelligent within overnight, right? Instead, there were three forces together, like there was better algorithm, we have more data, and we have some powerful computers. Today, we are going to go much deeper. We are going to understand why ChatGPT or any other AI tool become possible, why modern AI learns different from older systems, and why GPUs suddenly become one of the most valuable technology in the world. So by the end of this lecture, you're going to understand the real engines behind the AI tools or the modern AI systems. So let's begin. Like we've already seen this in the previous lecture, that most people is going to believe that AI become powerful because scientists invented just one magical algorithm. No. Okay, it is completely wrong. Modern AI exists because of three independent technology coming together. Okay, like for example, imagine you are preparing your favorite pizza. What do we need? First, we need a recipe. Without a recipe, you don't know what to do. Second, we need ingredients. No matter how good the recipe is, without flour, without vegetables, without cheese, without spices, nothing can be cooked, right? Third, we need a stove. Even with a perfect recipe and fresh ingredients, food won't cook without heat, right? So the algorithm is the recipe, the data is the ingredients, and the GPU, which is computing power, is your stove. Only when all three works together does AI become intelligent and smart. Okay, it's like imagine trying to cook a 5-star meal. Recipe is perfect, ingredients are perfect, but someone forget to switch on the stove. What is going to happen? Nothing. Exactly the same thing happens in AI also. Okay, can you think of another real life examples where three different things must work together? Write examples in chats. Let's explore the first ingredient. Algorithms. Better algorithms. From rules to learning. Okay, so this is where AI is going to change completely. Let's go back 20 years back. Earlier AI systems are going to behave like strict rules. Okay, everything had to be written as rules. For example, if an image has 4 legs, it has whiskers, it says meow, then it's a cat. Simple. But here are the problems. What if the cat is sleeping? What if only half the face of cat is visible? What if the lighting is poor? What if it's a cartoon cat? Then your computer becomes confused. Why? Because human cannot possibly write rules for every situation, right? Imagine asking someone to identify every tree in the whole world. Would you write 1 million rules for it? Obviously, that's impossible, right? Instead, you simply show thousands of pictures. Eventually, the person naturally understands what tree looks like. That's exactly how AI works today. Modern AI doesn't wait for programmers to write rules. Instead, it studies billions of examples. Slowly, it is going to discover the patterns on its own. This process is called machine learning. And then we use very large neural networks. We call it deep learning. So Google Photos doesn't recognize your dog because someone programmed every possible dog breed. It learns from millions of labeled images. Getting my point? Same goes for Tesla also. Tesla doesn't identify pedestrians because engineers listed every walking style. No, it learned from enormous driving datasets. Similarly, there are some corners where AI is going to shift towards you. This signal shift from programming intelligence to learning intelligence is probably the biggest revolution in the computer science. Okay, so let's make this even more practical. Okay, like for example, spam detections. Let's compare old AI with the modern AI that we are going to use today. using something everyone has already experienced: spam emails. Within years ago, email systems worked using simple rules, right? Like if an email contained free, which is FREE, it was marked as spam. Sounds good, right? But scammers quickly adapted. Instead of writing free, they wrote FR33. Getting my point? Or F space R space E space E. Or they can use different images or text. Here, the system failed. Why? Because it only knows some fixed rules that is there, which is if it is free, then it's spam. Today, AI works very differently. Instead of checking just one word, it is going to analyze thousands of characters simultaneously. Right? That who sent the mail, how often, what is the writing style, what are the sentence patterns, if there is any link or not, if there is any attachments or not, okay, how was the formatting, what was the previous behavior. Modern AI learns hidden relationships that humans would never think of. So when Gmail moves spam into your spam folder, it isn't because someone manually wrote millions of rules. Okay, it's AI continuously learning from billions of emails. Imagine trying to identify fake currencies. Instead of checking only one security features, bank examine dozens of tiny indicating together. Modern AI works exactly the same, guys. Okay, so have you ever noticed Gmail catching spam before you even see it? That's AI quietly working behind the scenes. So AI learns from example, but where do all these examples come from? Yes, data. Huge data. Okay, imagine teaching a child mathematics. Would you give only one example? Of course not. The more examples the child sees, the better they understand. Deep learning, or else I can say AI learns exactly the same way. Instead of reading one textbook, modern AI studies enormous amount of information. Millions of books, billions of photos, images, research papers, videos, computer programs, scientific articles, maps, languages, medical records, satellite imagery. Every type of information helps AI learn patterns. Think of AI as a student who never gets tired. Instead of reading 10 books, it is going to read millions. Instead of solving 100 mathematical problems, it studies billions. That's why modern AI appears so knowledgeable, because it has already worked on huge data. When you ask ChatGPT about programming, history, biology, or mathematics, it isn't searching the internet in real life. It generates answer based on pattern that he had run during the training process, right? So then, coming towards the next part, if you could train an AI on only one type of information, would you choose books, medical records, video, or scientific research? I repeat the question. If you could train an AI system on only one type of information, like books, or medical records, or videos, or scientific research, tell me your choices in the comment section, that which one you're going to choose. Now we have algorithms, right? So like for example, before starting with the algorithm, we have algorithms, we have data, but there is one big problem: computational power, CPUs, GPUs. Imagine I ask a student to solve 10,000 problems. Okay, could they finish in one day? No. Now imagine 10,000 students, each student is just going to solve one problem. Suddenly the impossible task becomes possible, right? That's exactly how GPU works. Traditional CPUs are excellent for handling few tasks quickly. GPUs are designed to perform thousands of calculations simultaneously. That is what we call parallel computing. Training modern AI models involve enormous amount of mathematical operations. Without GPUs, training today's large AI systems would take far longer than a lot of time. Okay, this parallel processing is one of the key reasons AI has advanced so rapidly. Okay, so companies developing large AI models use vast clusters of GPUs working together for weeks or even months. Think of it building a skyscraper. Would you hire only one worker, or you're going to hire an entire construction team? The larger the project, the more parallel work need to be done. AI training follows the same principle. So in the next lecture, we will move from understanding how AI learns to seeing what it can actually create. We will explore one of the most exciting capabilities of the modern AI, which is image generation. How can a computer create a picture that never even existed before? We will find out. If you have enjoyed the lecture, don't forget to like and subscribe to the channel and share it with someone who really wants to understand the ground up from the AI. Okay. In the next lecture, we will step into the fascinating world of AI image generations. We are going to discover text, how a text becomes image, and we can discuss the risks of deep fakes and why transparency is essential for responsible AI. Thank you so much.